You ever stand in front of the fridge, knowing you should grab the salad but your hand just reaches for last night's pizza? That's not a failure of willpower, it's a biological turf war happening inside your skull. It is a high-stakes battle between your brain's CEO and its inner child. On one side, you have the prefrontal cortex, or PFAC. This is the sophisticated, logical part of your brain that thinks about long-term goals, consequences, and what's best for you tomorrow. It's the part that signed you up for that gym membership. But on the other side, you have the limbic system, a primal, emotional powerhouse that screams for what it wants right now. This system is all about immediate gratification and avoiding discomfort. Most of the decisions you later regret happen when this impulsive inner child hijacks the controls from the logical CEO, leading you straight to that cold slice of pepperoni. So why does the pizza so often win? It all comes down to the brain's internal currency, dopamine. We often think dopamine is the pleasure molecule, but that's not quite right. It's more like the anticipation molecule. Your brain isn't just choosing what feels good. It's choosing what it predicts will feel good. This is a process called the reward prediction error. Imagine you expect a task to be boring, but it turns out to be fun. Your brain gets a surprise hit of dopamine, way more than it predicted. That dopamine surge essentially tells your brain, hey, pay attention. That was better than we thought. Let's do that again. This creates a powerful reinforcement loop, wiring you to repeat behaviors that deliver unexpected rewards, whether that's finally cleaning your garage or scrolling through social media for another hour. But not all decisions are a conscious calculation of rewards. Sometimes you just get a gut feeling. Well, neuroscience says that gut feeling is very real. Neuroscientist Antonio Damasio introduced the somatic marker hypothesis, which suggests that your brain doesn't just store memories of events. It stores the physical sensations that went with them. Think about a time you made a bad investment. You don't just remember losing money. Your brain remembers the sinking feeling in your stomach, the sweaty palms, and the racing heart. Later, when you face a similar risky choice, a part of your brain called the ventromedial prefrontal cortex subtly replays those bodily feelings. It's not a mystical sixth sense. It's your brain using past physiological data to give you a quick, intuitive warning or a green light. That vibe you get from a situation is literally your body's wisdom speaking to you from the past. If your brain is so smart, why is it also so lazy? Because it's an energy hog. Your brain makes up only about 2% of your body weight but consumes a whopping 20% of your daily energy. To conserve this precious fuel, it follows the law of least effort. It defaults to what Nobel laureate Daniel Kahneman called System 1 thinking: fast, automatic, and intuitive. This is the system that lets you drive a familiar route without thinking about every turn. System 2, on the other hand, is slow, deliberate, and analytical. It's what you use to solve a tough math problem. Because System 2 is so taxing, your brain avoids it whenever possible. This preference for cognitive ease is why we stick with the default option, a phenomenon known as the status quo bias. Changing your mind or your habits requires real metabolic energy, so your brain often decides the easiest choice is to just not choose at all. So after all this internal conflict, reward prediction, and gut checks, how does your brain finally pull the trigger and make a choice? It's like a neurological election. Scientists call it evidence accumulation. Inside your brain, specific neurons essentially vote for different options. In areas like the lateral interparietal cortex, some neurons will fire more actively in favor of option A, while others will rally for option B. They gather evidence from your memories, emotions, and senses. This neural activity builds up over milliseconds. Like two candidates gaining votes, the decision isn't made until the firing rate for one option hits a critical threshold. Once that line is crossed, it's the point of no return. A definitive signal is fired off to the motor cortex, telling your body to act, to click the button, say the words, or reach for that slice of pizza. The choice is made.